No, I did not. All right. 4.1, graph, and yes, we will be graphing. Quadratic functions in standard form. I'm just going to let you know pretty much this whole chapter is graphing, so. No, I'm not kidding you. Have you all graphed parabolas before?
Yes.
Good answer. I know you have. Huh? Yeah, so basically this section we're doing it in standard form. Yeah, probably the easiest. No, actually no, it's not. It's not the easiest. Then we'll do it in vertex and intercept form. And just for the record, we're spending today and Wednesday on this stuff. We'll do it, well, we're going to solve them by factoring. So right now we're kind of solving by graphing. Then we'll solve them by factoring. Yeah, anyways. So yeah, just be ready to graph. Because I do make you do that. So anyways, alright, so a quadratic function, its definition. Yep. Quadratic function is a function that can be written in standard form y is equal to ax squared plus bx plus c, where a is not equal to 0. The parent function for quadratic functions. I'm going to show you what the graph of it will look like. You're going to need some space to write around it. So just make sure you have some space there. Give up. Alright, so this point right here, okay, is the lowest point, okay, or highest point if it's flipped upside down, but in this case the lowest point on a parabola. Okay, so this is called a parabola. So the graph of a quadratic function is a parabola. So the lowest point on it, or the highest point, as the case may be, of a parabola is a vertex. For the parent function, vertex is at 0, 0. Okay, and then this line that goes through the middle is called the axis of symmetry. What? No, because the parabola keeps going. That's why it has arrows on it. So it keeps going all the way up. That's fine. Just this whole line here is the axis of symmetry. And it won't always be, like, on the y-axis, okay? A lot of times your axis of symmetry will be shifted. Okay, this is just for the parent function. If you want to shorten this, When you do axis of symmetry, you can do AOS. Okay, because I will have you tell me, like, okay, where's the axis of symmetry, stuff like that. But the axis of symmetry divides the parabola into mirror images and passes through the vertex. So I'm going to go ahead and give you a little hint. If you find your vertex, okay, your axis of symmetry will always be at whatever the x-coordinate is, but it's written as a line. Okay, the axis of symmetry is written as a line, x equals something, okay, because it's going to be a line going up and down. Okay, if you have your axis of symmetry, you have your x point of your vertex. Okay, so if you're given one or the other, you can find the other one pretty easily. Okay, so just like a little hint before we get too far into this stuff. Alright, let's look at some properties of the graph. So properties of the graph of y is equal to ax squared plus bx plus c. Alright, so this first one is going to be y is equal to ax squared plus bx plus c for a greater than 0. The other one, y is equal to ax squared plus bx plus c for a less than 0. Yes to the first and yes to the second. My class that I just finished taking proved that. Correct. Real analysis. It's mostly words, not math. Alright, so this one, alright, so there is it graphed. So my axis of symmetry, okay, we do it with a dotted line usually. No, mine's not either. Okay, this line is at x is equal to minus b over 2a. Okay, in both cases. Okay, that's the formula for it. Okay, the point where it crosses. Okay, you're always going to have to find basically 2 points when you do this, okay? You have to find the vertex, so that's a point. You have to find one other point. The easiest point to find is when it's on the axis, okay? Because what's going to happen is there's equal amount of space here as there is here. Okay, it doesn't look like it in my graph, but there is. Okay, so if you find the point on the right side, if it's 3 from the axis of symmetry, you go 3 the other direction, you found your other point, and then you can draw it. Okay? So, once we do more examples and stuff, once we do examples at all, it'll make sense. But Okay, so then this point where it crosses the axis, okay, is 0, C. Okay, and I'll give the characteristics of it on another page here in just a second. Yeah. Nope. I'm going to give you a true day off. Everybody have this stuff? Anybody still need it? Good. Okay. Alright, so let's look at some characteristics of these graphs. I should rephrase. We might get to some examples, but we'll also do more on Wednesday. So no, you won't have any homework tonight. Alright, so characteristics of the graph of y is equal to ax squared plus bx plus c. Alright. Huh? There's 4 points. Some of them might take 2 lines, so. Alright, the graph opens up if a is greater than 0, and down if a is less than 0. Okay, so I'll move this in a second. But a greater than 0, okay, that's what we had drawn here. So this graph was opening up. A less than 0 over here, that graph opens down. The graph is narrower than a graph of y is equal to x squared if the absolute value of a is greater than 1. Okay, and for this we're going to say that it is compressed Yeah, we did it. We just talked about the transformations, and now we're actually going to be graphing them and finding like zeros and stuff like that. If. And it'll be wider if the absolute value of a is less than 1. It's expanded. The axis of symmetry is x is equal to minus b over 2a. The vertex, I'm splitting these into 2 separate points because I felt like they should be split, so there actually is going to be 5. The vertex has an x-coordinate of minus b over 2a, so that's what I kind of mentioned before. Our axis of symmetry, wherever that is, it's going to be the x-coordinate of our vertex, okay, and vice versa. And then the last point, the y-intercept is c, so the point 0, c is on the parabola. Okay, so that means when x is equal to 0, y is equal to whatever our c value is, okay, out of our equation. So this is a lot of stuff, I know, but if you just know these patterns, like x is minus b over 2a, okay, and that It's negative, but make sure you pay attention to if our B or our A are negative, what happens to it, okay? The vertex has the x-coordinate of that, and then you have the y-intercept point, which if you get the y-intercept point, like I said, it's really easy to get the point that's on the other side of the graph to be able to actually graph it. All right, so then the last thing that goes with this stuff is minimum and maximum values. In case you're trying to fit everything on a page, this is going to have a couple lines of like notes and then some like pictures of graphs. Yes. Alright, so for y is equal to ax squared plus bx plus c, the vertex y-coordinate is the minimum value of the function if a is greater than 0, and it's the maximum value if a is less than 0. Okay, and just so you know, we can write this as min or max. Okay, if you want to, like when I say, tell me what the min is, tell me what the max is, you can say min is blah, blah, blah. You don't have to say like minimum every time or maximum every time. Okay, you don't even have to graph it to see this. Okay, you can literally just use the formula for vertex to find it and then figure out from there what it is. So, alright, so since we still have some time, let's go through an example. Actually, I'm going to stop this video so that